PLC stands for Programmable Logic Controller and is being widely used in many areas and industries such as water, power, mining, oil and gas, transportation, manufacture. In today's topic, we're going to be talking about the PLC in general. And one of our engineers going to give us a general understanding of the PLC and some fundamental knowledge of the PLC as well.
PLCs are a really good substitute for hardware implementations. So normally we have a range of relays to control different factory automation processes, whereas we can actually do this all electronically, digitally in a PLC. So in a PLC, for example, ladder logic, we have contacts and we have coils. Contacts basically act as relays, more of an electronic version, whereas coils act as the outputs for driving, say, a motor. Contacts is basically the same as a boolean, where it can only be 1 or 0, and it's more or less an on-off switch, the same as a relay. So instead of having 20 different relays, you can condense it down into one logic program, one ladder logic program, and drive, say, a motor or a robotic arm or whatever you might need in a factory automation process. Not only can you do relays or simulate relays in software, we can also use function blocks such as counters, timers, even more complex things, whereas arithmetic, for example, adding function blocks, multiplication, and so on. So everything can be simulated in code. For example, we can do really complex operations, for example, PID loops. PID is proportional, integral, and differential. So instead of having either on-off, you have a gradual increase or decrease in value to determine flow. If you have flow on a pipe, we want to gradually increase the flow or gradually decrease the flow. Whereas if you just have an instantaneous on-off operation, this would create a shunt, which more or less directs a large volume of water down a pipe. This would, for example, if you have something downstream, like a smaller pipe, the pipe would burst. So we can use a PID loop to open a valve or close a valve, and this will stop any potential damage to a system. For programming PLC logic, we can use instruction list or sequential function charts. We can also use structured text or ladder logic diagrams.
I hope you enjoyed this video. I hope our engineer has given everyone a brief, a general understanding on the Programmable Logic Controller, that is the PLC, and with some typical applications as well. Friends, fellow engineers, you can see the quality of our engineering work is very high. Engineering training sits at the heart of our business. We are ensuring our engineers are well trained so they can grow on their technical ability, together with professionalism and the leaderships as well. We believe all these will help our clients to have a better products and help our engineer to deliver a better product to our clients as well.